All right. Okay. So I was saying that tan theta is y over x. And we're saying y over r divides by x over r. And this would be y over r times r over x, right? And that would be y over x. So that is what I was trying to show you here. I hope we all agree to that. If you don't agree, you can raise your objection. So that's what I was trying to show here. And that simply means, of course, y over r is the same thing as sine theta, and x over r is the same thing as cos theta. So we have been able to show that. The same thing applies to cot. Obviously, you can actually just say by reciprocal rule. If you say that, I'm going to give you a full mark for if I ask you to show cos theta equals to cos theta over sine theta. If you simply say by reciprocal rule, then you can have cos theta over sine theta. That's fine. Otherwise, you may also want to show it like we have shown for tan theta. And just let us see that cos theta over sine theta is the same thing as cot theta. Whichever way you've done it, you're going to have your full mark from that. Now, the second problem is to prove the Pythagorean relationship. The first Pythagorean relationship is sine squared theta plus cos squared theta equals to 1. And using this same graph that I've drawn, we have that x squared plus y squared equal to r squared, okay? And if you divide this a, that's what I've represented as a, by r squared, remember r squared is what should be 1, right? We want the right-hand side to be 1. So that is why we're dividing all through by r squared. If you do that division, you're going to have x over r squared plus y over r squared will be equal to 1, right? And what is x over r? X over r simply means sine, right? And what is y over r? That is cos. If you substitute that, you're going to show that it's sufficient to show that sine squared plus cos squared equals to 1. All right. So I want you to do this assignment on your own to show 1 plus tan squared theta equal to sec squared theta, and 1 plus cot squared theta equals to cosec squared theta. You should be able to do that on your own. If you have any challenge, you can ask for a tutorial. Okay. Now, how do we simplify trigonometric expressions? It is usually preferable to reduce your trigonometric function to a simpler form. Obviously, when you have a complex equation, the first thing that comes to mind is how do we reduce the complexity to a simpler form of equation? And that is what we'll be doing. We can use all of these trigonometric identities, okay? or trigonometric relationship and identities to simplify a trigonometric expression. I'll say that again. We can use any of our trigonometric relationship and identities to simplify a trigonometric expression. All right, let's look at this example. We want to simplify sine cube theta plus sine theta cos square theta. How do we simplify this? Obviously, this sine cube we can be represented or can be simplified into sine times sine square. Is that correct? Can be factorized, can be simplified. So sine times sine square. Okay, and that is what we'll be doing. We want to factorize this. That will be sine square theta plus cos square theta into brackets sine theta. By the time you multiply this, you're going to have about the same thing as we have in A. And from the Pythagoras, we have sine square theta plus cos square theta is equal to what? I will stay there. Are you guys still awake? It's 1. Okay. So we have 1 times sine theta, which gives us sine theta. You can see how useful that trigonometric identity works for us. It has helped us to quickly simplify this sine cube theta plus sine theta cos square theta, and we've been able to obtain our value, our function to be equal to sine theta. The same thing with example B, 3b. We have cos square theta over 1 minus sine theta. In this case, cos square theta from our trigonometry, our Pythagoras is what? When we have when we have sine square theta plus cos square theta equal to 1. And here we have been given cos square theta. So we can represent it as 1 minus sine square theta, right? And that's what we have done here. 1 minus sine square theta over 1 minus sine theta. If you also factorize 1 minus sine square theta, it is 1 minus sine theta into 1 plus sine theta. Sorry, this is theta. And then you divide it by 1 minus sine theta. These will cancel out each other. You'll be left with 1 plus sine theta. That's it. That's actually the advantage of using those identities and relationship. So I've given you these 10 guidelines to verify your identities. Okay, I believe you have read through it and you can also read through it. But we're going to use some of these guidelines to solve some examples. Okay, let's look at this example. We want to verify this identity, tan theta plus 2 cot theta equal to sine square theta plus 2 cos square theta over sine theta cos theta. I'll be picking different guidelines. I'll be picking from that guideline. Now have picked guideline 5. And what does this say? We'll go back. It says use only substitution and simplification procedures, which allows you to work on only one side of an equation. Use only substitution and simplification procedures. Okay? Now, how do we do that? The right-hand side is the most complicated side. You look at which side of this equation is most complicated. Obviously, this is the most complicated, the right-hand side. Then what we want to do is to then convert our right-hand side to the left-hand side. And how do we do that? We want to use the properties of fractions and substitutions. That is what guideline 5 says. Use the properties of fractions and substitution using basic trig relationships. Now, we're considering this side, the right-hand side. Let me just draw a box around that. We're considering this right-hand side, okay? It's the first thing we want to simplify. How do we go about it? We want okay, sine squared theta plus 2 cos squared theta. I say we can use the property of fractions, which is sine squared theta. We take the first fraction, will be over sine theta cos theta. Then the second fraction plus 2 cos squared theta over sine theta cos theta. Do we agree with this property of fractions? If you don't agree, please say that you can split a fraction into two like this. Okay? And then what we have is from the first fraction, this first fraction, this. Okay? We have obtained this. And what we have done is divide this by this is a sine. So we're left with sine theta over cos theta. Let's go to the second fraction. Okay. The second fraction is this. And you have cos. This is cos. Divide this. You're left with 2 cos theta over sine theta. Right? Now, this shows that what is sine theta over cos theta? Tell me what is sine theta over cos theta? Your trig ratio, what is, okay, it's tan. So you have tan theta plus, what is cos theta over sine theta? Your trig ratio, yes, plus 2 cos theta. Now we have been able to show that the right-hand side equals to the left-hand side. All right? Now, we want to look at this second example. I would have preferred that you do this yourself, but like I keep saying, practice a lot of exercise. I want to verify these identities, sec x over cot x plus tan x equals to sine x. What guideline are we going to use? Let's go back. I've given the guideline just to help you. Use substitutions to change all trig functions to expressions involving only sine and cosine and then simplify them. All right? So remember that the right-hand side is just sine, and most of the like you have the function on the left-hand side, you have sec, you have cot, you have tan. So guide 8 says simplify all of these to expressions with only sine and cosine. Okay? And then you simplify them. Then trig ratio of sec is the same thing as 1 over cos. Trig ratio of cot is the same thing as cos over sine. Trig ratio of tan is sine over cos. By the time you simplify these, you're going to be left with your final answer will be sine x. I don't want to go through all of it, but Please work this out. Let me give you time. Let me give you like 5 minutes to work this out and confirm that you have gotten your answer to be sine x. Please, 5 minutes. I'll leave it here, but I want everybody to work out this process and see, confirm on your own that you have sine x. I'm giving you 5 minutes to do that. If you could not get sine x, please point and let's talk about it. Indicate. Are we winning? Does anyone have any challenge with this? Are we winning? Are we winning? Hello, everyone. So, who has any problem with this? Did you all obtain sine x? I need response, please.
Yes.
Okay. So, please, okay, Wabiza, what did you obtain? Wabiza? Adam, what we have done is just to, it's like a common factor between the denominators, okay? And that is just to be able to simplify the expression. You don't understand how we got cos x sine x over cos x sine. That's just multiplying the numerator and denominator by the common factors, okay? You want me to demonstrate it? I think because of our time, we're just on the 16th slide, and we're going to 40 slides. So what we can do is let's make a plan for tutorial. Okay? Yeah, it's just like you're multiplying by 1. Cos x sine x over cos x sine x is 1, basically. And remember, cos x sine x is, let me just demonstrate it here so you can see what's, okay. You have cos x plus sine x over sine x over cos x, okay? What this means is, what is the common factor between the two denominators, right? Is sine x cos x, right? That is the common denominator that is common to both fractions. So, and that is what we have done. That is why we have selected sine x cos x, or you can make it cos x sine x. And you multiply that by this expression, by this fraction. So in this case, this will be cos x sine x. This will multiply by cos x sine x. That's all. That's all we have done. It's same thing as saying, okay, cos x over cos x sine x over cos x sine x will give you 1. All right, that's how we have obtained this. And why we are multiplying it is to be able to simplify. For instance, cos x sine x times 1 over cos x will give you what? Will give you sine x, this. And when you express this, we give you this. Okay? And this will be equals to sine x. This by Pythagoras equals to 1. And that is why we have sine x. If you need further explanation, we can schedule a tutorial. I just want to know if there's a need for tutorial in any case. Because I see I've been taking so much time to explain in details most of these things. But if you still need tutorials, we can schedule that and we'll discuss most of these things in details in the tutorial, solve much more questions in the tutorial. But because of our time, I need to go on.